Cape Canaveral, December 1995. Satellite SOHO hangs in space at a special point, 1,000,000 miles out, where the Earth's gravitational pull is just as strong as the Sun's. This solar-powered solar observer ends up balanced between the two. NASA, Goddard Space Flight Center. Scientists here studied the images that SOHO sent back to Earth for several years. But in 1998, Mission Control lost those images when SOHO spun away from the Sun and its power failed. All they could do was wait and hope the spacecraft would rotate back to face the Sun. Slowly, it did. Pictures from the SOHO gallery. If our eyes could see ultraviolet radiation, then the Sun would look something like this. X-ray vision shows bright, hot patches. Look in the light of helium, and a turbulent rim is revealed. Here, gases are moved by an invisible force. The patterns we see on the Sun are the same as the magnetic field lines round a bar magnet on Earth.
Magnetism molds, shapes, and constrains everything we see on the Sun. It energizes powerful explosions. It heats the solar corona. Invisible magnetism rules the Sun.
The Sun is so hot that its hydrogen atoms are ripped apart. What's left is plasma, a seething fire of electrically charged particles. And wherever there is magnetism, plasma will spin. Here, nothing is still. This wild whirlwind is a solar tornado 1,000 miles wide. And beneath the bright visible surface, convection lifts massive plumes of plasma from the pressure cooker below. The Sun is constantly in motion. Maps show that the plasma moves at different rates in different layers. Red is faster, blue slower.
Electrical particles are swirling around inside the Sun, faster at the equator, slower at the pole, and that difference in motion produces the magnetism of the Sun.
The McMath telescope. The heart of this observatory is a hole in a hill, with a mirror on the top. Don Jennings has come here to study the Sun's magnetism.
The tube that telescope is built in is supposed to be a very constant temperature. And so having it inside a mountain is like having it in a cave. The air inside the tube isn't as turbulent, and it gives a much sharper image. It has a mirror at the top that tracks the Sun, and it sends a beam down 300 feet into the side of that mountain to another mirror that takes that beam and focuses it, forms an image right where we have our instrumentation set up.